Alright, in this video we're going to learn how to do orbital diagrams, which an orbital diagram is a representation of the electrons within an atom. So it's going to be important for us to remember what we learned in the previous video about the quantum mechanical model. So remember that there were three different rules, and the first rule was the Aufbau principle, which was the order of fill. So lowest energy to high energy is the order. And we're going to use this sheet to sort of remember the order for now. Now, the second was Paulie's exclusion principle. Okay, and with Paulie's exclusion principle, remember that was only 2 electrons per orbital, and they have opposite spin. Okay, so just a reminder that we have, remember we have our n number, okay, and it's going to have certain orbitals, and the orbitals within that electron or within that are going to hold 2 electrons each. So remember that n equals 1 has the sublevel, it has the s sublevel, kind of write that up in the corner, and therefore it has 1 orbital and it can hold 2 electrons, right? And then in the second shell, or the second energy level or principal quantum number, we have s's and p's, which gives us a total of 4, because the p has 3 and the s has 1, and so we have 8 electrons. And then in the third energy level, we have s, p's, and d's. And remember, we have 1, 3, and 5, so that's going to be 9, or a total of 18 electrons. And then in the fourth, we have s, p, d, and f, which would be a total of, what's that, 9 plus 7, that's 16, so 32 electrons. Okay? So just keep this in mind when we do our first orbital diagrams. Now, the last rule is Hund's rule. And the Hund's rule says that electrons won't share an orbital until they have to. Electrons won't share orbitals until they have to. Okay, so let's go ahead and I'm just going to do an example of one orbital diagram. Okay, so I'm going to pick an element on the periodic table, and we need to know how many electrons that element has. So let's just go ahead and look here, and I'm going to pick, right here, I'm going to pick phosphorus. So if we zoom in, remember phosphorus has an atomic number of 15, so that means it has 15 protons, and it's electrically neutral, so it's going to have 15 electrons. Okay, so what I do is I start by writing the letter or the symbol, right? Just so I know which one I'm doing. And I'm going to write up here that I need to do 15 electrons. So let me zoom out so you can actually see what I'm doing. So I need 15 electrons, right? So we need to follow our order of fill according to this little chart here. So the first 2 electrons are going to go in the first energy level in the s sublevel, and remember it only has 1 orbital, so it's going to hold 2 electrons. So below I'm going to write 1 for the sublevel, or sorry, for the energy level, s for the sublevel orbital, and there's going to be 2 electrons in there. Now, how I draw an orbital diagram is I'm going to draw a box, and that's going to represent the s orbital. And because of Paulie's exclusion principle, we know that 2 electrons can fit in there, and they have opposite spins, and we're going to represent them with arrows. So we're going to spin 1 arrow up and 1 arrow down. Now, the next electrons then are going to go into the second energy level in the s sublevel. So I'm going to write 2s2, and now I'm just going to keep a count, right? I'm up to 4 electrons now. And down here, I'm going to draw the orbital, which is 1 box, because the s only has 1 orbital, and we're going to have 1 arrow up and 1 arrow down. All right? Now I follow my arrow around like this, and I get to the second energy level, the P sublevel. And remember that the P sublevel has 3 orbitals. So instead of just one box, I'm going to draw 1, 2, 3 boxes, okay, for a total of 6. So now I would be up to 10 electrons. Now let me show you how I represent Hund's rule. Now electrons will not share the same orbital till they have to. So what they're going to do is one's going to go here, one's going to go here, one's going to go here, before we double up in any individual orbital. All right, now let's keep following along. I'm up to 10, so I've got 5 more electrons to show. So I go from 2p and then follow down, and the next area that's going to fill is the 3s. So I've got 3, the third energy level, and we're going to fill the s orbital first. So I draw 1 orbital for the s, and I'm going to do 1, 2, and I'll put my 2 here. I'm up to 12. Now I have 3 left to represent. So look back at my chart, follow my arrow up and around here, and I come to 3p. So the third energy level, the p orbitals, which we'll draw 3 boxes. Okay, and remember they won't double up until they have to. And I'm already at 12 electrons, and I need a total of 15, remember, for phosphorus. So I only got 3 left to show, so they're not going to pair until they have to. So they're going to split themselves up in those 3 boxes. And instead of putting a 6 here, I only have 3 electrons, so I write a 3. Okay, so this is the orbital diagram for phosphorus. Let me go ahead and just do one more, and I'll do it a little bit quicker than I did the last one, and we'll do something that's a little bit more challenging. How about we go ahead and we do selenium? Selenium is number 34. So I'm going to do it very quickly. So selenium is 34, and I'm going to start with 1s. So 1s, there will be 2 electrons in there, 1, 2. And then we go to 2s. I'll just follow this up here until I have to look back at my chart, right? So 1, 2. So now I'm up to 4. And then 2p, 3 boxes for the p orbitals. Up, down, up, down, up, down. I'm up to 10. Next that comes along is my 3s. This will bring me up to 12. 1, 2. And then I'm going to do 3p, and there will be 6 in there, and that will bring me up to 18. Okay, so I've got 16 more to do, so let's look where I go from 3p. Right, so 3p, remember that the third energy level has a D, but that overlapping causes the 4s to fill up next. So we got to follow our arrow down. So instead of going to 3d, I'm going to go to 4s. So 4s2, so that'll bring me up to 20. Okay, now next I'm going to go from 4s, now I do the 3d. And remember that D's, there are actually 5 orbitals, so I'm going to have to draw 1, 2, 3, 4, 5 boxes. And 10, that will bring me up to 30. 10 there. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I have 4 left to do, and I'll just draw it down here because I'm running out of room over there. And so after 3D comes the 4P. So I'm going to have 4p, and I only have 4 left, right, to get to my 34. So before of them, p has 3 boxes. So I'm going to do 1, 2, 3, 4. And that is the orbital diagram for selenium.